Hello, everybody. My name is Nicolas Cabrera. I'm going to be the TA of this class, Machine Learning for Biomedical Engineering. This is my email if you want to reach me or contact me. And the professor is Dr. John Hanks. If you are curious about my previous works, these are the titles of them. Those are published. And today we are going to learn TensorBoard, what does means, what are the function of it, what we can do with it. And it is a tracking and visualize metrics such as loss and accuracy. Both of them we used in our previous code. And there are different tools that we can use, such as color, images, graphs, distribution, and histograms. We are going to focus on a few of them. Here I'm going to use the same code that Dr. Hanks explained you how it works. The name is 01 chapter 2 collet 1 walkthrough / TensorBoard. It has the same lines of code, and I add these two in order to use the TensorBoard. What does this line mean is that I bring TensorBoard from TensorFlow that cares that callbacks, and I define the callback as a TensorBoard, and the object is TensorBoard. This log there tells the code where do I want to save the files. Also, I add I pass into the neurofeed, put it a callbacks equal TensorBoard because I define with that name over here. To run all the code, I'm going to restart everything. I'm going to run all cells. I'm going to use SGD. And yes, until we are waiting for that, I'm going to show you that TensorFlow has different optimizers. These optimizers are, but all of them, in the code that Dr. Hanks showed you, we use SGD. And with TensorFlow, we are going to compare this with Adam, FTRL, and Adam Delta. We are going to use those 4 optimizers in order to compare which one is the best for this database. Here we go. We have the 10 epoch. We have our training set, our test set, our training set, and we need to run the TensorBoard. To run the TensorBoard, we should go here. I'm going to clear everything. Okay, we are going to use the TensorBoard. So notice that I'm in the folder that I have my code here, and there is this folder. It's called logs. So I'm going to use this code, TensorBoard / log dir logs / and it will run. And here we have one link. That is the link that we are going to use on our web browser in here. So we are going to paste it. And here we will have all our models. If you want to check only one of them, you should hit on here. We're going to check the SGD model, which reached the plateau after the 4th step, and also for the loss and the accuracy. You can smooth your curve or not. And I already ran these other methods in order to compare and see which one is the best. And what we can see in here that this orange model, which is Adam has the highest accuracy value and the lowest loss value. So we should supervise if there is not overfitting. How we can do that? We can go to our code. We are going to change our optimizer for Adam, and we can use Adam 3 epoch. I'm going to name it like this. Why? Because as you can see in this TensorFlow, it reached the plateau on step number 3. We can zoom it. So in in epoch number 3, it reached a plateau. And for the last, also it kind of reached a plateau. It is not a big change between 3 and the 9 epoch, and it's going to take us less time to do it. So I'm going to put it 3 epoch for this Adam optimizer. I'm going to restart everything, and I'm going to run all the cells again. This I am doing because I want to prove that there is or there is not overfitting of the model. How we can do that? We can compare the accuracy of the training set versus the accuracy of the test set, and the values should be closer between each other. And here we have, this value is higher than the test set, but those values are closer. Another important tool that we have here in TensorBoard are the graphs. The graphs is a graphical representation of our code, specifically the layers. And I want you to remember that our input was 28 times 28, which if you multiply, the answer is 784. And here you have, with this layer, you have 511 neurons. And with second layer, we have 10 neurons, which means 1 neuron for each number. As you can see here, we have the 784 bytes of information of the input, because it's the size of the images. And after this value, this input get into the layer, it changed for 511 neurons. And these 511 neurons are going to change for only 10 neurons, that is one for each number. This is a graphical representation of the code of the layers, and as you can see, there is the softmax, the ReLU, those are the activation that we used. And thank you. I hope you enjoyed the video, and if you have any questions, please reach me out, email me, or Google it. Thank you. Bye.